5.4. The fundamental theorem of calculus. In calculus, we have talked about derivatives, and now we've talked a little bit about integrals and what they represent. In this section, we're going to relate the connection between integration and differentiation. This is arguably the most important computational discovery in mathematics. The fundamental theorem of calculus is broken down into two parts. So first we'll talk about the first part, and then we'll move on to the second part. If f is continuous on an interval a to b, then the function f of x is equal to the integral from a to x of f of t dt, and has a derivative at every point x in the interval a to b, and the derivative of f with respect to x is equal to the derivative of the integral of a to x f of t dt, which is equal to our original function f of x. What this means is the definite integral of a continuous function is a differentiable function of its upper limit of integration. So again, if I take the derivative of an integral, I will get back my original function, but instead of using t dt, I'm going to be in the variable of my upper limit. This can be used in order to determine both derivatives and integrals of a function, as well as compute very complex integrals. In the next examples, we're going to show how to use this theorem in order to solve actual calculus problems. Example 1. Determine the integral. So what we're going to do is we're going to use this integral, take the derivative of it to get our original function back. So remember, an integral reverses a derivative. So if you take the derivative of an integral, you're going to get your original function. The same way as if you integrated a derivative. So it's very important also that you're taking the derivative with respect to the same letter as the upper limit of integration. Without complicating this too much, it's very easy to do. All you have to do is rewrite the function, and the new variable becomes the upper limit, which is also the same letter of differentiation. And you're done. That's all there is to it. So right now on your own, I want you to try part B. Pause the video, try it out. Alright, let's see if we can do it. So first thing we do is check to make sure these match. Good, they do. And so now all this is going to be is 1 over 1 plus x squared. And that's all there is to using the first fundamental theorem of calculus. I know this might seem ridiculously simple. The upside is, it is. All you have to do is replace the variable with the new letter of differentiation. After you do that, you've taken the derivative of the integral. However, there is very serious work and clever thought that was put behind this very simple conclusion. If you look on page 294 in the book or down in the notes online, you'll see the proof that goes into it, which takes some tricky thinking.